Okay, got the last three properties of integrals. They're numbered 6, 7, and 8 up on the board here. All of these are assuming that we're working on an interval from A to B. Now, once I write that that's my interval, A is to the left of B. Interval notation we always give from left to right. So, we just saw in the last video that having these as my limits of integration does not necessarily imply that A is to the left of B. However, if I use interval notation, it is always left endpoint, comma, right endpoint. So here I do know that A is going to be less than B. If I hadn't written that, I'd need to just write it out as an inequality to indicate that I am, for all of these properties, integrating from left to right. Okay. All right, this one says if my height function is bigger than or equal to 0, then the signed area I get will be bigger than or equal to 0. Positive height gives me positive area. I think that's kind of common sense. It's kind of neat. Okay. All right, this one says if f is bigger than or equal to g, so this is the bigger height function, the bigger height function is going to give me the bigger area. Again, nothing super surprising there. Sort of common sense if you think about what the definite integral means in terms of it being a signed area. And then this last one just applies that to this inequality. If there's some number little m and some number big M, so that f is always in between those. So, for example, like sine is always between -1 and 1, so is cosine. So if I have a situation like that, where there's a floor and a ceiling and the function always stays between those, then I can just apply property 7. I can take the integral of each of these things, and the inequality will be preserved. But if I integrate a constant height of m, I'm going to get the area of a rectangle. The base would be b minus a, the height is little m. This is what I get if I integrate f. This is what I get if I integrate big M. Now, we're not going to spend a whole lot of time with these properties. I did want to make sure that I pointed them out. But one thing that's nice is that you can sometimes use these to catch careless mistakes. If I were integrating, let's say from 3 to 4, x squared dx, that function is positive on this interval, and I'm integrating from left to right. I know I'm going to get a positive answer. If I get a negative answer, I know I've made a mistake. So sometimes if you get an answer, you're sort of like, that seems weird. You can use these properties to say, is that actually weird? Have I made a mistake? Is it worth my time to go back and look for a mistake? Or is this just a surprise? But when I look at it, yeah, it actually kind of does make sense. Okay. That's the primary way that we'll be using these semester. They're important to know. But I didn't assign any of the homework that explicitly asks about these things. But I did want to point them out, especially because that sort of common sense check of, I got a negative number, does that make sense? Or sometimes I got a positive number, does that make sense? Can be really helpful in just catching careless mistakes.